Welcome back. Another beautiful day to do some more math. Here is the topic of today, top common mistakes working with radicals. All right, I did a couple of these examples in the one of the videos before, but I decided to do the entire video just for radicals in every possible way, just short of talking about the radical functions, but this is just the operational work with the radicals. All right. I've got two columns. One is don't do. That means no, 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 no. None of these is right. And the other one is perfect. The blue one, perfect. Yes, that's what you have to do. And that's what we're going to talk about. First one, distributing the root over addition and subtraction. So here it is. We got a square root of a plus or minus b. A lot of my students actually make a mistake that they think that the same rule applies for multiplication and division, and no, it doesn't for the addition and subtraction. So what does that mean? So so these are not obviously not true. The only way that they are true if you're multiplying the two radicals like that, or dividing becomes the square root of a over b. So do not do this. And as an example, look at this one, the square root of 9 plus 16. That is not equal to a square root of 9 plus a square root of 16, because the answer in here will end up being 3 plus 4, which is equal to 7. But the actual answer of a square root of 9 plus 16 is a square root of 25. But first we have to do the inside the bracket completely, and the square root of 25 is 5. All right, next one. Adding or subtracting unlike terms. Aha, this is another one. This is actually a kind of the reverse form of the rule number one that you shouldn't be doing, the distributing the root over the addition and subtraction, but one step further than that. So if you have a square root of a plus a square root of b, and a lot of students, they make a mistake of saying that, oh, that's a square root of a plus square root of b, the same thing as in example one. But more importantly, they have not only in the form of this example, the square root of 3 plus square root of 5 equal to the square root of 8, which is wrong, obviously, we just showed that, but also they add unlike terms. See, root 7 and root 5, they are not like terms, right? These are not like terms. So because they're not like terms, you can add or subtract them. So in this case, you can't just say 2 plus 3 is 5 and 7 plus 5 is 12. So the only way you can do this, let me give you an example of what you can do. If you have 2 root 5 plus 3 root 5, you have root 5 and root 5. That means not only the radicands are the same, 5 and 5, but the index is the same right here. That is, both of them are square root. So if this was 2 cube root of 5 plus 3 cube root of 5, they consider to be like terms again, so you can add them. So in here, the top one, yes, that becomes 5 root 5, and the bottom becomes 5 cube root of 5. That is okay. But number 2 on this side, the red, it is not okay because you cannot add unlike terms. Excellent. Let's move on to the next one. Not finding the largest perfect square factor when simplifying. Now, this is not a mistake, but what it is that is an incomplete answer when you are asked to simplify a radical expression. So in here, I give you an example, the square root of 72. A lot of students, what they do, they say, oh, right away, 9 times 8 is 72. That's brilliant. Yeah, sure. 9 is a perfect square factor because that's what you do to simplify radicals. You find the perfect square factor. But you have to find the largest perfect square factor. Largest perfect square factor. And 9 is not the largest perfect square factor of 72. It's 36 is, right? So if you get to this part, 3 root 8, then you're not complete. We have to go one step further than that. Either you do it right away, you can just start with saying that this is square root of 36 times 2, which end up being 6 root 2. Or you have to break this down again. This becomes 3 times 2 root 2 because 8 is 4 times 2, and 4, square root of 4, it comes out to be 2, and then that would be it, and the answer will end up being 6 root 2. So you must find the largest perfect square factor when simplifying fully, and that's what you're expected. All right. Now, number 4, not knowing what conjugate term is to rationalize the denominator. This is very common. It is a little bit more complicated, but the idea of conjugate, I ask my student, there's one thing that you just have to know. The conjugate of two terms, the conjugate of A minus B, simply is A plus B. Simple. And the reason we call it conjugate is because when you multiply them, they create a difference of squares. And through difference of squares, you use that to rationalize the denominator, meaning you get rid of radicals from the denominator. That's what you use it for. So a lot of my students, what they would do, they're like, oh, okay, you have for example, a question like this, 1 over 1 minus root 3, and the question is rationalize this denominator, and then right away they say, okay, well, I got to get rid of this root 3, so I'm going to multiply top and bottom by root 3. The idea of multiplying top and bottom, that's a correct idea, but what it is that you're multiplying with, that's incorrect. So these are not conjugate of each other. So the conjugate of 1 minus root 3, now I wrote a couple of examples here. So square root of A, square root of B is not a conjugate, not, right? This is not a conjugate. These are not conjugates of each other, all right? So you have to change the sign so that they create difference of squares when you're multiplying them, and that way it will work. So what is, and it's exactly same as the top here that I explained, A minus B and A plus B. So the conjugate of a square root of A plus a square root of B is a square root of A minus a square root of B, and vice versa. Okay? And so was this one. Square A minus root B, the conjugate of that one, and to each other is A plus the square root of B. Simple as that. So for this example, 1 over 1 minus root 3, you multiply top and bottom by 1 plus root 3, and after that, you notice that you get 1 plus root 3 on top, but the denominator, this is your difference of squares. When you multiply them, you get 1 minus 3. And 1 minus 3, that's just negative 2. And look, the radical has been eliminated. 1 minus root 3 is not there anymore because the entire thing is irrational. 1 minus root 3, so it's just negative 2. All right, so here it is. That's another one, number 4, common mistake. So make sure you avoid that. Number 5, not finding the higher order roots. This is usually confusing for most students. So when I ask them to simplify cube root of 8, they think that cube root of 8, they just treat it as a square root. So they just say, oh, this is just square root of 8. And then they simplify it as 2 root 2. But that's not true, because cube root of 8, you must find. So cube root of 8 means you have to find the perfect cube factors and the largest one. Okay, so what is the largest cube factor of 8? Well, 2. 2 cubed. So that becomes cube root of 2 cubed. Well, that's 2. Okay, that's not 2 root 2. So that's why you have to be aware of that. Now, if this was the quartet, that means that this was the 4th root. And make sure you have to find the largest perfect quartet factor. Okay, the 4th factor, the 4th root factor, I guess that's what I have to say. But they can't quartet as well, triplet. Okay, so that's it. Be careful with that. Not finding the higher order roots, that's another common trap. All right, the next one is the equation base, forgetting the 2 solutions. I talked about that before, but I'm going to do it again. Most often students just say the square root of x squared is x, and be careful with that. When you do this, the answer to this one is not just one value, is 2 values. So square root of x squared is equal to absolute value of x, which is equal to plus or minus x. okay? Two values, positive and negative, because of the definition of the square root of x squared, or the square root. And that's the solution to this equation. So you're forgetting the two solutions, you only have one solution, and you forget the negative. So be aware of that one. Number 6. Number 7, not isolating the radical term in the equation. So oftentimes the idea that, oh, okay, so we have this equation, square root of x plus 1 plus 2, I just made an example here for you, equal to 3. So they know that the first step is to go ahead and square both sides. Once they've done this, then they go ahead and they square root of x plus 1, a square is x plus 1, and then 2 squared is 4. And equal to, and then of course they square the other side too. Now, one part of it is correct, one part of it is not correct. Is squaring both sides of the equation, that's a correct step. Very good. But the way they have done the expansion, my students, some of my students would do the expansion, that's incorrect. So you have to isolate the radical first. So how would you do that? This is what you would do. You would just say square root of x plus 1 equals to, you subtract 2 from both sides, that would be 3 minus 2, which is equal to 1. You get the square root of x plus 1 equal to 1, and then you're going to follow all the song and the dance of solving radical equation. Look at this. The square root is being isolated and then on its own, and then you solve it. If you don't isolate this, and if you even don't make this mistake right here, and you go ahead and use the binomial expansion to expand that, you will not be able to solve this equation because you're making it more complicated. You're going to add work for yourself to solve this simple radical equation to make it more complicated. So don't do that. Just isolate the radicals. Okay, once you isolate it, then you go ahead and solve. Okay, number 8, and that's the last one, forgetting to check for extraneous root. I gave you an example here, square root of 2 plus x equal to negative 1, and I want to walk you through this example together, and I'm going to show you what that means. For the most part, we have, let's go through, so square both sides, 2 plus x is equal to, let me actually do the math. So here we go, first step, and this is what most students do, by the way. First step is very good, is correct. Then they say x equals to, subtract both sides from both sides, and then you get x equals to negative 1. Okay? That's what you will get. Very good. Now, they forgot to check. What happened is that when you plug the negative 1 back into the original, you'll get square root of 2 minus 1 equals to negative 1. That means the square root of 1 equals to negative 1. Is that true? No, it's not true. And if it's not true, that means this is an extraneous root or solution. Okay, that means it doesn't work. So make sure you check for extraneous root after each solution. Okay, every time you must check for extraneous root and put it back into the original equation. Fantastic. 8 of the common mistakes that my students, and still some of them, they still make the same mistakes. I hope you don't make these mistakes now that you're aware of it. Fantastic. Check out the next video about radicals or operations in radicals or functions. And until next time, keep at it. See you then.